So in the BME Design Lab, we are using human-centered design to engineer devices for children with complex medical conditions so that we can decrease their cognitive delay caused by physical disabilities and therefore increase their social inclusion as well as their autonomy.
Our patient was having trouble using a spoon due to limited dexterity as well as the inability to do a scooping motion normally. We went in and used 3D printing to make this original prototype of the spoon. And we wanted to have the patient interact with the spoon and hold it to see if it was something that would actually be helpful. And after we saw him holding it, we realized that a counterweight was really important in order to actually balance what was on the spoon, and that this piece right here, which we thought might actually help him hold it, actually wasn't needed and didn't help him. So then we went through and redesigned it a little bit, keeping the same angle and the same scoop, and just changed the length of the spoon.
So we're working with 3 different patients right now. One of them is working on feeding that you saw with the spoons. The second patient we're working with, we're making some sort of device to help motivate them to do their physical therapy because they're working on leg strength to eventually help them get out of a wheelchair and stand up and be more autonomous. And the third patient is we're designing a scooter that would help them move around their house so that they can not have to use their bulky wheelchair and be able to get on the scooter and get off the scooter themselves even though they don't have movement in their legs.
So a tangential project that we also worked on was what we coined the Cruiser X. So that was for the patient that we've also been working on the spoon feeding project for, whereas this one was based on mobility and autonomous movement. So the whole goal was to create something that was different from a power wheelchair, which is bulky and slow and looks like a medical device, and instead create something that looked more like a toy. So it looks like a tricycle or a power wheels, and it's more inviting and more fun than a bulky medical device. So we brought the original prototype to the patient's family. From there, we did some more iterations on the tricycle. We were able to get feedback from them on the design and how well it fit the patient. Then we did the edits, brought the tricycle back, and were able to see the patient use it and really enjoy it a lot. And it was really awesome to deliver the tricycle to the family and see how much of an impact it could make on them, and see how much our innovations and designs could really help another person and help the patient. And it's just really rewarding program.
We just received it a couple of weeks ago and Charlie loves it. And we still have some tweaks on it, but it's moving, he rides it. It makes other kids want to come near him when he's on it. It looks like a little hot rod car, and so I think for other kids to be able to want to socialize with him, it makes Charlie happy, and I think other kids then won't be so scared of approaching someone with a disability like him. So these young ladies have volunteered to help our family and help Charlie in developing equipment that he can actually use. Charlie has several therapists ranging from PT, OT, speech, and several physicians. But when we order equipment sometimes through them, it can take up to months, 6 months or more to get a piece of equipment. And so with these young ladies, it can get to us faster. It's more specific, more designed and geared towards Charlie. And it doesn't have to be adapted from a commercial piece. So it's a time saver, but it also gives, I think, the student opportunity to work with children or young adults on projects that are going to affect those individuals.
So part of our design process is actually visiting the patient's homes and getting a holistic view of the situation that the patient is in. And this really adds a lot of depth to our design process because it allows us to see exactly what's going on, exactly who they're interacting with, exactly how they're feeling in their natural environment. Because once you go into a clinical setting, you don't necessarily feel that because you kind of put on a show for the doctors when you're coming in to see them. And so being able to go to their house really gives us that other side of the story. And this is really helpful for us. And then also, when we actually, in the end, give them our devices, we can see like naturally how they're going to use them and how they're going to interact with them and see if it's right or not, and then being able to fix that if it's not right, but also being able to like give them the devices and have them keep them and actually have them impact their lives in a way that they weren't able to find those opportunities before, because our devices are so customized for their specific needs.
I knew I wanted to study biomedical engineering because I wanted to work with patients, but I knew that I didn't want to be a doctor. And so this project has been really exciting for me because we've been able to help people in a less conventional way than you'd normally see like in occupational or physical therapy or in like a hospital setting. And it's been nice. We've been able to go and meet with the families and talk with the patients and the families and see what they felt they wanted and goals that they had, and then go back and talk with the therapists and doctors and make it a cohesive team to try and work towards those goals and fill a need that couldn't be filled with a normal device that you could buy in a store.
So I'd say the most impactful part of this project is getting to work with real patients. So in a lot of engineering and a lot of traditional labs, you don't get to actually see the end result of your research. What's different about this is we're working directly with patients, directly with their families, directly with their doctors and physical therapists, and it really just makes everything seem a little bit more real life, and that we're actually doing something to make a difference in someone else's life, which is really what I want to do with my education, is be able to make an impact on others. And so I just find this project and this program and its goals a really great way of using engineering skills and engineering design to improve the quality of life for someone else, which is pretty awesome.